2011, number 1. Here we go. We have a nice particle motion. Is the speed of the particle increasing or decreasing at t equals 5.5, and give a reason? So for part A, now remember, I have the formulas for velocity and acceleration, not position. For part A, I want to find the velocity at 5.5 and acceleration at 5.5, all on my calculator. Both of these are negative. Therefore, the speed is increasing because velocity and acceleration have the same sign. For B, find the average velocity of the particle over the time period 0 to 6. If I want average velocity, I want to integrate velocity. So to find the average velocity, I'm going to integrate velocity from 0 to 6 and divide by 6 minus 0, which is just 6. Integrate on my calculator, divide by 6, and I get my final answer, 1.949. Don't forget 3 decimal places, and notice I'm not rounding until the end, so keep an eye on that. Part C, find the total distance traveled by the particle from 0 to 6. Total distance means you want to integrate the absolute value of velocity. So I want to integrate, and again, all on my calculator, integral of, you can even type in, using your vars key, absolute value of y1, integrate from 0 to 6, and you get your final answer there. Part D, for 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. So first step of this, we need to find out when the particle changes direction. And the particle changes direction when velocity is 0 and you have a sign change, because if velocity is positive, you're moving to the right. If velocity is negative, you're moving to the left. So when I look at my graph here, if I'm looking for when does when does the particle change direction, I want the x-intercept. That's the piece of this that I want, the x-intercept, because this is my velocity graph, when velocity is 0 and has a sign change of plus to minus. So that sign change signifies the change in direction. So I have to find the time when that's happening. So I find that 5.1955. Now I need to find the position at that time. If you recall, to find the position of the particle, you have to get the original starting spot. We were told that x of 0 was 2. That was given to us. So that's my original position, plus the displacement, which is the integral of velocity from 0 to my new time. So I integrate this on my calculator, so I get 2 plus, and that's what I get on my calculator. So for a final answer, my new position is 14.135.